Welcome to day 4. Here we will look at the iteration or repetition or loop statement. The terms can be used interchangeably, and we shall look at indefinite iteration by way of the while loop. How to make use of the video. 1. Just watch the video like a TV program. 2. Take notes with pen and paper, pausing the video intermittently. 3. Open up the Python idle editor and type and run the programs. Or you can watch the video several times and do something different each time. The important point to remember is that you have choice and a great deal of flexibility and versatility in how you use the videos. So let us look at the while loop or indefinite iteration. Okay, if we go back a bit, let's look at the for loop, which is an example of definite iteration as covered in day 3. So we can make the contrast between definite iteration and indefinite iteration. So this program here, program 1, produces this output here, 0, 1, 2, 3. So how does it do it again? For j in range 4, print j. So the first value of j is 0, and it prints j, which is 0. Goes round the loop again. The second value of j is 1. Prints j, it prints 1. The third value of j is 2. It prints j, it's 2. And the fourth value of j is 3, and it prints j, which is 3. So it's gone round the loop 4 times and printed 0, 1, 2, 3. Now here, remember, Python is a zero-based language, which means we start counting from 0, as we have done so here. Just by way of information, general knowledge, there are other programming languages which start counting from 1. Now, we can make use of the while statement to produce this same output. And here is the while statement in program 2. Let us see how program 2 is working. K equals 0. While k is less than equal to 0. Well, k is 0, so it is less than equal to 0, 3 rather. So these next two statements are executed. Print k, so we print k, which is 0 there, and then let k equals k plus 1, so k becomes 1. Then it goes round this loop again, while k is less than equal to 3. Well, k is now 1, so k is less than equal to 3 because 1 is less than equal to 3. So these two statements are executed. Print k, you print 1, let k equals k plus 1, k becomes 2. Go round the loop again. While k is less than equal to 3, well, k is 2, so 2 is less than equal to 3. So these two statements are executed again. Print k, printed 2, let k equals k plus 1, k becomes 3. Go round the loop again. While k is less than equal to 3, well, 3 is less than equal to 3. So these two statements are executed again. Print k, k is 3, k equals k plus 1, so k becomes 4. Go round the loop again. While k is less than equal to 3, well, k is now 4, so it's not less than equal to 3. So these two statements are not executed, and the control of the program drops out of the while loop. Now, the while loop is an example of indefinite iteration, which means the number of times we iterate or repeat or go round the loop are not known beforehand. As in the case in the for statement, which is definite iteration, you know definitely how many times you're going to go round the loop. But in this case, every time you try and go around the loop, you evaluate a condition, and if it's true in this case, k is less than or equal to 3, then you go around the loop. But if it's false, then you exit out of the while loop. So the while loop implements indefinite iteration, and the number of iterations is not known beforehand. That's what it means. Or we can say the while loop is also known as a condition-controlled loop, i.e. the loop is repeated based on a certain condition. So in this case, this loop is repeated on the condition that k is less than or equal to 3. Now, we are going to look at program 3, which also makes use of the while loop. Now, in this program here, let me just briefly describe it before we go into details. There is a password which is secret. So secret, the password variable has been assigned the value secret. And in this loop here, the user types in the password and he or she types in a password, and the program goes round and round and round until the user has typed in the correct password. And when he or she has typed in the correct password, control of the program drops out of the while loop and you get a message saying, well done, you have entered the correct password. So let us see this program in action. Okay, we are looking at the program in more detail now. So here are these comment statements talking about what the program is about, and here is the program repeated here. And now let us run it. Enter password. Let's enter chocolate. No, try again. Let us enter bread. Try again. Let us enter secret. Well done, you have entered the correct password. So how is this working? Password equals secret. So there is a variable called password which has been assigned the value secret. Now active equals true. There is a variable called active which has been assigned the value true. Now active is what we know as a flag variable, and it will become apparent later how this flag variable is working. Suffice to say, a flag variable is quite useful when dealing with while statements. So it's used in conjunctions with while statements quite often. So while active equals true, or rather while active equals true, which means is active equal to true? Well, it is, isn't it? Because we have just assigned the value true to the variable active in the line before. So execute these statements here in the while block. User underscore passwords equals input enter password. So it prints to the screen enter password, and it is expecting a input from the keyboard. So we have typed in the word chocolate, and it has assigned the variable user underscore password to chocolate. So then it says if user underscore password equals secret, meaning is user underscore password equal to secret? Well, no, it isn't. It's equal to chocolate in this case, isn't it? So we don't execute the next statement. We go on to the else and we say try again, and it's printed to the screen try again. So then it goes back up here. While active equals true. Well, active is still true. So it executes the while block again. User underscore password equals input enter password. So it's displayed to the screen enter password, and we've now typed in bread. It's expecting an input, and so it's assigned the value bread to user underscore password. Then it says if user underscore password equal to secret or equal secret. Well, it's not, is it? It's equal to bread. So it doesn't execute this next statement here. The flow of control passes to the else, and it goes to print try again, and here we get try again. Then it goes back up here, whilst active equal true. Well, it's still true, so it still executes this while block. User underscore password equals input enter password. Now we've typed in here secret, so user underscore passwords equals secret. So here it's asked if user underscore password equals secret, and it is in this case, so it executes this statement active equals false. So active now changes from true to false. And then it goes back up here while active equals true. Well, now active is now false. So it does not execute this while block. So control of the program falls out of the while block and it comes down here to print well done, you have entered the correct password. So here it has printed well done, you have entered the correct password. Now what I suggest that you do, that you pause the video and you type this program in and you get it working. And you learn this construction off by heart, because this type of construction is very useful and it will be replicated when you write other programs. So, for number 17, write a program which asks the user to input a number and repeats until they guess the number 7, and then congratulates the user with a well done when they guess correctly. Let us look at number 17. Now, let us look at how number 17 runs first of all. Enter a number, 4. Try again. Enter a number, 5. Try again. Enter a number, 7. Well done, you have guessed the correct number. So this is the program which produces this output. How is it working? Number equals 7. The variable or number is assigned the value 7. Active equals true. The variable active is assigned the value true. Now, in this case, active will be a flag variable, and it will become apparent what we mean by this. So whilst active equals true, well, is active equal to true? Yes, it is. In the line before, we have assigned the value true to active. So we execute this block of code within the while statement. User underscore input equals int input enter a number. So here we've got enter a number. We enter 4 because the program is expecting an integer as denoted by the term int. So user underscore input is now equal to 4. If user underscore input equals number, so is user underscore input equal to number? So here is 4 equal to 7? Well, no. So it skips this statement here, goes to else and says print try again. So we've got here try again. Then it goes back up here while active equal true. Well, active is still equal to true, so we still execute this block of code within the while statement. User underscore input equals input enter a number. So this has printed this to the screen, enter a number, and we've printed 5, or typed in 5 rather, because the program is expecting an integer as denoted by int. So user underscore input is equal to 5. If user underscore input equals number, is 5 equal to 7? No. So it goes to else, print try again, and then it goes back up here. While active equals true, well, active is still true, so still execute this block of code here. User underscore input equals int input enter a number. So here we've got enter a number and we've typed in 7. If user underscore input equals number, so 7 does equal 7, then active is equals to false. So before active was true, now it is false. So active is like a flag variable. It flags up a changing condition. So active is now false, doesn't execute this else, and then it goes back here saying whilst active equals true, well, active is now false, so it doesn't execute this block of code within the while statement. The flow of control jumps out of this while block and goes to here, print, well done, you have guessed the correct number, and it's printed here, well done, you have guessed the correct number. Okay, my suggestion is that you go over this again, and maybe you should type this out and try it yourself. So, for number 18, write a program which asks the user to input a password and exits when the correct password is entered, and asks the user to try again if the incorrect password is entered. Okay, number 18. Let's see this run first of all. Enter a password. Bread. Try again. Enter a password. Egg. Enter a password. Chocolate. Well done, you've guessed the correct password. Now, this is the code for number 18. The code for number 18 is similar in structure to that of number 17. Password equals chocolate. A variable called password has been assigned the value chocolate. Active equals true. So the variable active has been assigned the value true. Active is a flag variable. It will become apparent what we mean by this a bit later. What's active equals true? Well, active is true, isn't it? We've assigned the value true to active in the previous statement. User underscore input equals input, enter a password. So enter a password, we've put in bread. User underscore input becomes bread. So if user underscore input equals password, well, is bread equal to chocolate? No. So the flow of control passes to the else statement, print, try again. We've got here try again. Back up again. While active equals false, true rather. Well, active is still true. User underscore input equals input, enter a password. So here, enter a password, we've put egg. It's expecting an input from the keyboard. So user underscore input becomes egg. So if user underscore input equal password, is egg equal to chocolate? No. Flow of control passes to else, print, try again. Try again here. Back up again. While active equal true. Well, it's still true, isn't it? User underscore input equals input, enter a password. So we've put in chocolate. So user underscore input equals chocolate. If user underscore input equal password, is chocolate equal to chocolate? Yes. Then active becomes false. So active changes its state from true to false. So it's a flag variable in that it is flagging up a change in status of the sort of program. So active is false. So it doesn't go to else, then go back up here. While active equals true, well, active is now what? False. So the flow of control of the program passes out of the while block and it comes out and it goes to here and it goes to print, well done, you have guessed the correct password. And here it prints, well done, you have guessed the correct password. So for number 19, write a program which asks the user to input a number and outputs the times table for that number and starts again every time it finishes. If the user enters the number 99, then the program exits. Here it says you must use both a while and a for loop to answer this question. Okay, let us run number 19. Enter a number 3. And here we have the 3 times table. Now let us enter 5. And we have the 5 times table here. Let's enter 99 because it says enter 99 to quit. And we have now quit the program. So how is this working? Well, we have a variable active which is assigned the value true. And again, active is a flag variable. While active equals true, user underscore input equals int input, enter a number, or enter 99 to quit. So we type in 3. If user underscore input is equal to 99, well 3 is not equal to 99, so control of the program passes to the else here. And here we've got a for loop for j in range 1, 11. So the first value of j is 1. K equals j times user underscore input. K equals 1 times 3. Print j, which is 1, times there, user underscore input 3 equals, prints the equals, k, which is 3. Goes round again. So next value of j is 2. K equals j times user underscore input. So j is 2, user underscore input is 3. So it's 2 times 3, k is 6. Print j, so j is 2, times, it prints the times there, user underscore input is 3, equals 6. So it goes round this loop about 10 times until it's printed 10 times 3 equals 30. Then it goes back up to the while statement there, which is while active equals true. Well, it is still true. User underscore input equals int input, enter a number or enter 99 to quit. So we've typed in 5. So user underscore input now is equal to 5. If user underscore input equals 99, is 5 equal to 99? Well, it isn't, is it? So the flow of the control passes here to the else, for j in range 1 to 11. Now the same rationale as produced this 3 times table will produce this 5 times table here. And then the flow of control passes back to while active equals true. User underscore input equals int. Enter a number or enter 99 to quit. So you pressed, or we typed in 99. If user underscore input equals 99, well, it has entered 99. So user underscore input is equal to 99. Active equals false. So this flag variable changes from status from true to false. So this variable flags up a change in status. So here it does not execute this else block. It goes back to the while active equal true, but now active is equal to false. So it does not execute this while block, and flow of control of the program passes out to print you have now quit the program. So it prints you have now quit the program. So this program uses both a while and a for loop.